Docker with Metana. Hi, my name is Tinal. I'm one of the student success instructors here at Metana. And for those of you who does not know what Metana is, we do bootcamps in multiple different segments, and our main two bootcamps are full stack and Web3 Solidity. So first of all, welcome everyone to the webinar Mastering Docker, and We'll get started right away. Right. So when it comes to Docker, give me a second here, right? Right. Alright, so I hope some of you guys might have an idea on what Docker exactly is. If not, worry not, we'll actually give you a nice idea, and you would simply pass this container onto that system, and then you would run this, and it would serve the same way that the container is supposed to run. And when it comes to virtualization, they are able to run multiple operating systems on a single physical machine through virtual machines, right? So that is the whole idea of virtualization. You would run multiple different operating systems on one host machine, and that would utilize the resources that are provided by this hardware, and it would cater to the need of running multiple different virtual machines. And when it comes to containers, they are quite fast, as containers don't need to boot an OS. They just need the kernel or else whatever the dependencies that are needed to run this application in that container. And it's going to be a very lightweight application. It's not going to need all of the outer hardware, the software needed to run an operating system. But when it comes to a virtual machine, it's a bit slower because the virtual machines need to run their, boot up their own operating system and all that, so it kind of takes a bit more slower approach. But let's say you have a really powerful system, then I don't think that virtualization would have that much of a lag between them. And when it comes to containers, they are more efficient, lightweight, and uses less system resources, because as I mentioned, they are not going to have all this the surrounding, they're not going to have all that unnecessary contents. It only will have all the components of your application and the dependencies that are needed to run this application within that container. So therefore it's going to be more efficient, lightweight, and use way less system resources. And they're not going to need a separate operating system to run these applications. And when it comes to virtualization, they consume more resources, CPU, memory, storage, due to this whole full operating system duplication. And when it comes to process level isolation, containers share the same OS kernel, so therefore they're not going to need another operating system kernel to be used for this. And when it comes to virtualization, full OS level isolation, each virtual machine has its own operating system. Well, some of you might ask, why Docker? Well, Docker definitely, the whole reason being that it simplifies application deployment, and it ensures consistency across deployment, development, testing, and production environments, reduces the infrastructure overhead, as well as promotes microservice architecture. Yes, that was a lot of technical terminology, but let me explain to you one by one. So when it comes to Docker, it simplifies the application deployment, because all you have to do is simply cover up whatever your application and put it into a container, and then you need to put this container up in a Kubernetes, some kind of a container deployment. So there's many of these services out there that already do that. So all you have to do is deploy this container into one of those, and they will run up your container with the necessary scripts that you provided. And when it comes to consistency across development, testing, and production environments, since you'll be passing this container around with the rest of the developers, they'll be easily accessible to get that same application that you've shared across. And the whole aspect of people saying that, oh, it ran in my computer but it did not work on yours, is not going to be a problem with you, because all you're doing is you're passing the same environment, the same Docker container around with the rest of your team. And it reduces the infrastructure overhead, because you're not going to need all the unnecessary infrastructure in order to run Docker containers. As I mentioned, they're quite lightweight and very easy to run them. promotes microservices architecture, which is something that is out there recently. As some of you guys might have heard, microservices is something that is out there in the world in a new manner, where you would have your services in small containers, and these containers is what we are going to use to serve your application. So in microservices architecture, instead of having everything in one monolithic approach, right? So this is what a application you would build nowadays, and you have the server and you would serve it to the front end. But in a microservices environment, you would, in a high level manner, you would break it down into different services, and then these services would provide separate basically they serve a separate purpose. So whenever you need something to be done by this specific service, it would perform that, and then that is the only service that will be used there. So when it comes to scalability, scaling your application, it's going to be quite easy for you to scale only that service, and not going to necessarily scale the rest of the services that are unnecessary or not seen very much of a need for scaling. And when it comes to so moving on, for anyone that is wondering about the architecture of Docker, so this is for the big ballers out there, who really want to get into Docker and get an idea on what Docker really is. We'll get into that. Docker has a different set of things. So the first main thing being the Docker client. There's going to be your client that you're going to use to interact with Docker and perform whatever you want to with Docker. So this is the way, this is your interface for you to interact with Docker. And when it comes to systems, we have a GUI as well as a CLI. So the CLI is what we normally use, and then we have the GUI that we use to interact, help the users, make it much easier for you to interact with this Docker system. And then we have Docker host, where the containers run. So this is where it's quite similar to a host machine, like where you would run virtual machines on. It's quite similar, where over here we are going to run Docker containers instead of virtual machines. And then we have Docker daemon. No, it's not actually a daemon. It's the service or the background application that does everything you do with Docker. It sits idly. So it sits idling in your machine, and when called upon with the use of the client, it performs the task that necessary. So either you build up a new Docker image, or else you boot up a new Docker container. Whatever it is, the daemon is what's in charge of making sure that it happens. And Docker Hub is quite similar to GitHub. So I'm hoping that majority of you guys know what GitHub is. So when it comes to GitHub, you use GitHub to store your code repositories, and here, instead of storing your code repositories, we store Docker images, and this serves as a place for developers, or people to basically store their image and in a public manner, or else you can either go into a private manner. You can save them, and then after that, when someone needs it, you can pull a Docker image and use that to build a container. So let's get started with Docker. So for you guys who have not yet installed Docker, this is the general way of installing Docker. So when it comes to Windows machines or a Mac OS machine or any kind of machine, you can straight away go into docker.com and then straight away get started with installing it. All you have to do is go into docker.com and then get the relevant installation, and then install it and run it on your machine, and it's going to be that easy for you to run Docker. Yes, it might require certain changes in your system, especially when it comes to Windows machines. You might have to allow certain permissions and things like that, but all that is quite easy. I'm not going to go through the entire installation process because I think that will take a bit longer time, and I don't think that you guys are sitting here to watch the whole installation process. But if you are on a Mac OS, and if you are someone who is using Brew, then you might be familiar with how to install applications using Brew. So that is one of the easier manners if you're on Mac, and if you're not using Brew, what are you really doing here? So definitely get Brew if you're not using Brew. Make sure that you use Homebrew to download Docker, because it will perform everything. It will get you Docker ready to run, and all you have to do is just run the application. So if you're going to use brew, just use brew install cask docker, and it will install docker as a GUI application and not just the CLI client. So when it comes to Docker, the key components, when it comes to Docker, Docker is not a one-man show. It has multiple different things. First of all, we have the Docker file, which helps with building the Docker image. It's where you state the configurations for your Docker image. And then the Docker image is what you generate out of the Docker file. So this is what you're going to use. It's quite similar to an operating system image. You're going to use this to build your Docker container, and this will have all the configurations, the scripts that are needed, and everything that is necessary for your container. And then we have the Docker container itself, which we'll be using for getting the so we have the Docker container, which we'll be using to get your Docker image, clone that Docker image and then run it on your Docker container as the application. And then we have Docker volumes, which is quite similar again to a volume in your system. So this volume is something that can be shared across Docker containers, and they help you to allow the user to share the data between the Docker containers. So one container can save the data or files in this Docker volume, and then another Docker container can make use of that files from that Docker volume. So when it comes to Docker, I'll take you through a small demonstration on how to work with Docker. So first of all, we need to find a Docker image. So the easiest way for you to find a Docker image is go to Docker Hub, because as I mentioned, it's quite similar to GitHub. So let me take you across this step. Right, so we have Docker Hub, which is you can simply type docker.com. You can simply type Docker on the Google search and get docker.com. And over here, once you come into Docker, make sure that you sign up to Docker, and then after that, you can go ahead and start searching the Docker Hub, going through the contents. So I am going to right. So I'm just going to use one of the Docker images that I have previously prepared. So this was one of the Docker images that I have used. It's a Docker Super Mario. So simply, in order for you to pull this Docker image, you're going to go ahead and copy the content, and then afterwards you are going to go into your terminal. Right, so you're going to go into your terminal, and then you will go ahead and let me see if you guys can see it, and we are going to go ahead and paste it in. So first of all, you need to make sure that you guys have Docker running in your system. So if you do have Docker running in your system, it should look quite similar to this. So this is what the Docker GUI looks like. And in order for you to make sure that you are able to interact with Docker, make sure that Docker is running in the background. So when it comes to Mac, you can have the GUI closed, but on your top taskbar, it will show that Docker is running in the background, and that is necessary because, as I mentioned, you cannot have the Docker daemon not running, because that's going to be what's going to be doing all of the background tasks. So we are going to have Docker running in the background like this, and then afterwards you're going to go ahead and pull the image. So let me go ahead and do that. Yes, some permissions here. Right, so let it do its thing, and it's gonna pull the image. Alright, so image is already up to date. So it seems like I already have the image. So let me just go into my Docker images here, and then afterwards, yes, so we do have the Docker image, and Right, so now we have done this step 2. We have already gotten the Docker image, and then next begin run a Docker container. So using Docker image to run the Docker container with the GUI, it's quite easy for you to do that. All you have to do is go ahead and press on this button here, and that will make it very easy for you to run. Obviously you're going to need to state certain settings here, but I think it's going to be much easier if you go into the repository, and most of these repositories would have the command for you to so it would have the command for you to run this application itself over there. So I'm going to copy that and go into the CLI here. Right, and then after that we are going to set it to run. Hit enter, and the requested images platform does not match the detected host platform. Right, okay, so it seems like we are either having some issues or else. Right, okay, so we do have the container running here, and let us view that container. Alright, so it is running fine, and we have Docker. This is Super Mario Bros. Running straight up from the Docker, and whenever I do not want to play Super Mario, I can simply go ahead and stop my container, and that just stops the entire application. And if I try to access the application from the same routes, let me just go into this localhost 8080. Now you can see that Super Mario Bros. Is no longer running, and if I want it to run again, I just have to start it up, and that's all I need to do, and we should have Super Mario Bros. Running here. Yes, there we go. So, and it just works just like another application. It's gonna use the inputs from your keyboards, and it's gonna be the same thing like how you would work with a. So yeah, that is what Docker looks like, and so yeah, moving on. Let me just close this up and stop the container. So there won't be really a problem with having your containers running throughout, but I would not recommend it. Obviously there's not going to be a problem because the Docker containers are quite lightweight, and it's not going to have much of an effect in this. But moving on, so as I showed you guys, you first of all find a Docker image, and then once you have found a Docker image, you can get the Docker image by using the pull command, and then run the container using that Docker image, and then access this container contents from the port that you have opened for this container, and now you have a successful Docker container running. Right, so that's right, I think we have a small slide error, but as I mentioned previously, the Docker file comes into play with the whole aspect of building an image, and I'm not going to get in depth into this whole building an image because it kind of takes some time, and I don't think that we have enough time to go through the whole process of building a Docker image. But when it comes to, I'm just going to skip that whole part of building a Docker image. You guys can drop us a comment or inform us if you guys need another session on building a Docker image, so that we can go through the whole process of configuring a Docker file and then building an image, and then getting it ready to push into Docker. Basically have that image as something that you can publish, and then maybe use that for containers. But we're going to skip that, go into the next stage, which is pushing an image onto Docker Hub. So it's going to be very easy for you to push an image to Docker Hub. All you have to do is follow the commands. When it comes to, it's quite similar to GitHub push and pull requests. Sorry, not requests, but GitHub push and pull. It's going to go through the same process, but instead of pushing some code, you're going to be pushing a Docker image. And once you do push that image, it will go ahead and show up on your Docker. So it's going to be something like, let me see if I have an example to show you guys, because again, as I mentioned, I do not want to take something that would take a lot of time. But yeah, so we have my profile, which would have, yes, we do have a Docker container that I have pushed onto my system, onto my Docker hub. So it contains an Express API, which I've done as an example, as well as a user service CI/CD. But yeah, so once you push it, it will be accessible for people to use it. So apparently they have a few pulls of this. Alright, we have 24 downloads of this, pulls of this container, sorry, Docker image, and seems like many people have made use of it. Not really sure why, but yes. So most of your repositories are gonna be public, and if you want, you can make it private. But this repository is a public one, which I made as an example, right? So that is what Docker is in a nutshell. And in a very high level manner, Docker is basically something like GitHub, but for all Docker images. And Docker images are very helpful when it comes to building Docker containers. Docker containers is a very simple form of building your applications into small containerized applications, which allows people to easily get them, get the container or the Docker image and then run it on their system. Makes it very easy for you to test out applications on different environments, and also helps with the process of adding pipeline in this entire process. Makes it very easy to automate. So if you guys are curious on how you can use this knowledge, how you can use Docker in your day-to-day life, for example, I normally use Docker especially when it comes to working with databases and working with applications that I need to run as a service, which makes it very easy for me to pull them up and use them. So yeah, that kind of concludes the whole process of working with Docker. And when it comes to questions, I hope if any of you guys have any questions, you guys can drop them out in the chat. I think you guys should have access to the chat. Let me see here. Right, so let me just turn on the chat here, and if you guys have any questions, you are welcome to point them out and I will answer them to the best of my knowledge. But if not, and for whoever's tuned in through the live to the Metana socials, you guys are welcome to drop the questions on the chats and we will get back to you on that. But if there's no questions, I think we can wrap up the webinar, and whatever questions that you guys have in the future, you can always drop them to our socials or else our open emails, and we can respond to them. So I think we have a few questions. Any DevOps bootcamps comes in the future? Yes, we do have a few bootcamps that will come up in the future. We have a advanced software engineering bootcamp that we've introduced quite recently, and we also have a few other bootcamps that we're going to introduce. I'm not going to get in depth into that here in a Docker session, but if you're interested, do check out our website and hit us up on the communication channels, and we will give you a much more in-depth idea on that. During Web3 development, which Docker flow do you suggest for safety? Right, so when it comes to Web3 development, so it depends, right, or based on whatever applications or whatever system, whatever architecture that you're going to work on. It's up to you to decide on what works out best, because when it comes to different systems, different things work out, and especially it depends on the environment. So if you're working on a Web3 system, and it depends on whatever environment that you're working on, because it's not going to be the same thing across all these different systems and environments. Whatever works for the Web2 segment might not work out for the Web3 segment, and whatever works out for Web3 might not exactly work out for Web2. So I would I'm not gonna be I can't really give you a proper answer on that. I think it's best if you talk to not talk to, but more like check out some online articles or any existing workflows when it comes to using Docker in your Web3 development kit, and see how it fits whatever the environment that you're currently working on. So if there's no other questions, I think we can wrap it up for today. And if you guys have any other questions in the future, you guys can check out our website and drop us any messages or any questions that you guys might have through the open emails, the info@metana.io, and we'll be glad to respond to them. With that said, I think we are going to wrap up the webinar. Thank you everyone for joining, and hope to see you guys at the next webinar. Hope you guys have a great day. Yeah.